Welcome. I'm here to make chemistry way easier, or at least I hope. That's my goal. I'm a tutor here in Bellevue, and my name is David, and let's see how we can make this work. My first lesson is going to be on stoichiometry and dimensional analysis. Oh, what fun. So this has everything to do with canceling units. It also has to do with something called the Molar Roadmap, although we're going to switch up the name on that one a little bit. So this, hopefully you've seen before. If not, not a big deal, but you will want to commit it to memory. We have what looks like a roadmap, but we're going to call it an office building. And it has 5 different offices. So here we have the grams office. Here is moles. This one's going to be particularly important. We'll come back to that later. Liters, which you will almost never use, but when you do use it, okay, it's helpful. Mostly, we don't care about that one. Molecules, or atoms, or ions. This looks like the most complex because it is, but the password to walk between those two offices is going to be very simple. Did I mention there are passwords in this office building? Yeah, that's right. There are guards in between the hallways. They will not let you through unless you know the password. And the final office down below is atoms, or ions. You will only use this for complex molecules. Read that as not very often. All right, let's talk some more about those passwords. So we have passwords between these offices. And if you want to walk from grams to moles, you must have a very specific password. Wait for it. Yes, indeed, 1 mole and the number of grams from the periodic table. That's also called the molar mass. You will have to add up all of the individual pieces, including subscripts. So, for example, our good friend H2O, the password to leave grams and go toward moles would be 18 here. 1.01 plus another 1.01 plus 16, technically speaking, we're looking at 18.02. Including units, grams. All right, now with this fraction, I've got some magical arrows here. I don't care very much about which one's on top or bottom. This can be flipped upside down whenever you need to. Just make sure that it's helpful for the problem that you're working on. What I mean by that is whichever office you leave, put those units in the denominator. Whichever office you're walking toward, put those units in the numerator. And using that, you can just envision which direction am I walking in order to figure out where my fraction goes for numerator versus denominator. So, let's talk about these other passwords. Liters, which you will almost never use, is just a simple number. 22.4 liters per 1 mole. Just like all the other fractions, I don't care which one's on top or bottom, the office you leave always gets put in the denominator. So flip it upside down as necessary. This one, that is a number that I guarantee you've seen before if it's after the 23rd of October. What's so special about that day? Oh, that's right. It's Mole Day. So, Mole Day is pretty awesome, let's be honest. But it's only awesome in this hallway. It is not used anywhere else. So many students think, I see moles, I need the mole number, that's 6.02 times 10 to the 23rd. That is not any time you go to the moles office, that is only reserved for this hallway, right there. 6.02 times 10 to the 23rd. If you need that on a calculator, make sure you press the EE button. That's right, we are going to scrap the times 10 to the 23rd, and we're going to do capital E 23. That will make your life so much easier for inputting these things into the calculator. Don't try to use times 10 to the 23rd. Use the capital E. Now the final the final hallway you will not use very often, but in the event that you're trying to find how many individual atoms there are in a complicated molecule, it goes like this. The subscript from the balanced formula, I mean the charge balanced formula, and one molecule. So again, back to H2O. If you were converting into atoms of hydrogen, it would be 2 atoms for every 1 molecule. If you were converting into atoms of oxygen, because the invisible subscript right here is really just a 1, then you would simply say 1 atom of oxygen for every 1 molecule of water. All right, very nice.